I think it's working.
It's streaming again?
I think so.
She's got it streaming. She's smart.
Hey, what happens up in my fingers? Am I gonna get shocked?
Your fingers are gonna get eaten away to the bones.
What'd you? This is over Unity. I don't believe you. It's over Unity.
Actually,
Perpetual motion.
Actually, it's pretty basic Ohm's law.
What's Ohm's law?
Ohm's law is watts in equals watts out.
What's a watt?
What?
Is this
I don't know what a watt is.
a Red Bull?
No.
I don't know what a watt is, but this can't work.
So we're up again? You sure it's up? It's on again?
We should ask for a Subway sponsorship.
Subway.
Eat fresh.
Commercial. Eat Subway.
He's been on the Subway
He's been
diet.
on the Subway diet.
Yeah.
He's been on the Subway diet.
I've been on the Subway diet and it don't work. I eat 3 of them every day for lunch.
I was gonna say something like nasty about the child molestation.
Yeah, don't go there.
Well, yeah. Yep. The two things it does too is this is a 1500 watt generator. Because of the increase in horsepower, it jumps and it burns so fast. It actually
That's bad. It was getting up that high.
Oh yeah, it's
bad.
That's serious.
I did it and I got videos on
That's bad.
but it doesn't. It goes extremely you can do the like that.
Hey, put the show on the road. Show on the road.
Take care of your girlfriend's hair.
Oh, okay. Well,
Hey, who's in charge of this place? Let's
I
get
don't
this
know.
show on the road.
Him.
No, I don't know what's going on. I just work here.
All right, where's the guys? Yeah, there he is.
No, I did. That's what I said, guys. I can't believe I said that.
Now that I got a mic, all right, everybody, come on back in. We got another speaker we're gonna have. Yeah, I'm gonna do next on the direct. It's more to keep me on target. That's a good idea. I'm not gonna be up for like an hour. Right. There's
100 miles per gallon.
Yeah.
Alright. All right, we'll start this off right here. Okay, we got another speaker. His name is Mark Cooper, and he has a website, 100mpgmotors.com. And currently, he is trying a kick car Lamborghini and computer controlling the vapors and even adding hydrogen here and there and really getting up there in the mileage. So I'll let him speak for this, and he's got a little presentation and see what he's got to do. Mark Cooper.
Thank you, everyone. So, this is more to keep me on track, so I forget where I am. So, some history. Can you hear me? There we go. Much louder. So, some history on some of these things I worked on. I've been looking at one of these jack of all trades, master of none thing for 12 years now, probably. Oh, he's coming up. He's coming up for that camera? Yeah.
Pause.
Time out.
I'm gonna go up there. I'm gonna walk around whiteboard. Because I know what it is. Okay, mic's good. Okay, recap. My name's Mark Cooper. Been searching all kinds of technologies that are alternative for about 12 years now. I've always been interested in Tesla-based things and whatnot, and read about the fumes and all that, and thought, you know, I don't know if I'll ever get around to doing that, because I didn't know how difficult it was, or easy, or what have you. So,
What I missed, Mark?
nothing.
Awesome.
So, 04, 05, I started really getting heavy into a lot of this, various technologies and reading a ton of material. I don't know how I did so much in a day, but still getting it done one way or another. So, fumes. All right, let me just start from there. I got too many different things in my head that I want to cover, but I'm only going to talk about fumes in this segment, because otherwise we'll be off the wall before long. So about fumes. So for things that I've actually produced, that started December 2012. I did a patent search and found 964 different patents going over 100 years. So the oldest patents I found was from 1912. That guy was doing 205 miles per gallon on a Model T or A, I forget which one. And, you know, it was a very simple bubbler type thing, actually, is how it was designed. I studied that a lot, that particular patent. There's probably about 4 different patents that I've looked at in a lot of detail, and to see what's similar about them, what's the common thing, right? Because I'm not doing anything new. I mean, geez, 1912. So the thing that you find in common with all of the ones that definitely exceed 100 miles per gallon, they all warm the fuel. They keep it dry. It's straight into the intake. There isn't like a long path, and you know, the stuff Tom Mogul did in '78 time frame. He actually ran fumes from the gas tank at the back of the car to the front. Okay, well, we're talking about air moving in a vacuum. That's 1,100 feet per second at sea level. A few feet from the length of the car, that's no distance. So, and you can actually read through his diary, if you will, you know, of how it went. You know, he started doing one thing and then he realized, oh yeah, this is gasoline, so it's a solvent. You know, it's sitting in a vacuum, it wants to freeze, so I gotta add heat to it. You know, it gets really efficient. He starts opening the throttle more, and now he's like collapsing the gas tank. Because there's all these, without getting into too much math, there's all these flows and orifice sizes based on the stream's direction all the way down to where the valve is opening to pull it into the cylinder. So there's a lot of math to know about this stuff, and this guy was just kind of working with what he had in his hands and figuring it out as he went. And then directly following reading all these patents and reading Tom Ogle's work and whatnot, I went out on YouTube. Okay, let's see who's got stuff out there. Everything under the sun's out there by 2012. Let's see if there's any 100 mpg type stuff. So I went out there looking, and I come across this guy on YouTube. His name was Sunny5 Rising, and it was the, I don't know if I'd call it inspirational, but it was the video that I watched where I seen how simple this was. I thought, you gotta be kidding me. It can't be that easy. You know, really? So I'm looking at this thing. The guy's got the carburetor off of his little Briggs & Stratton motor, little single cylinder motor, you know, ran his air compressor. Had his air compressor tore down. He was cleaning it up, putting fresh paint on it, going through the air compressor. He's like, well, I've got this part. I thought I'd try this fumes thing out and see how it goes. So he has a little 1-inch T, a couple of 1/2-inch bushings, 1/2-inch lines coming off, 2 ball valves. One's going to the fumes on the gas can, one's going straight out to the air. Really? So I'm looking at his gas can. He's got a hole drilled in it. He's got another 1/2-inch line where it goes inside of the tank. There's only about 1.5 inches of fuel in the bottom of the tank. And he's just breaking the level of the fuel. So as air's being sucked into the tank, it's bubbling the fuel and agitating it and helping the fumes keep coming. And the whole tank stayed warm. I was like, that's it? So yeah. And I already knew about the gate stuff. I'd read about that, you know, and whatnot. So I went from a Sunday afternoon, 1 p.m. on a Sunday afternoon, watching Sunny5 Rising's video, ran over to the Geek website, used it as a parts list. I pretended I had nothing. I got all kinds of little pieces, parts I tinker with, all this stuff. Pretended as if I had none of that stuff at home. What do you got to do to go build this? Went to the Geek site, pulled the list down for the single cylinder 1-inch intake. It's good up to 20 horse. Okay. Used that as a parts list, went to Lowe's. $82 in parts, back to the house. It was the T, close nipple, 1/2-inch reducers, hose, a couple of ball valves, hose bar, hooked it all up, plumbed it all up, got an old generator out. I haven't fired it in 6 years. Been sitting around, you know, the thing's all gunked up on the liquid fuel side because I didn't drain the bowls in it. So I fire that thing up, second pull. This thing hadn't run in 6 years. And I had no idea about, you know, air-fuel mixture. I just choked it off like a normal motor would be that's carbureted. You know, it's going to be a little more rich. So I put a little more rich to the fume side. And yeah, the second pull, it finally pulled enough fumes up through the whole tubing and all the way up into the system. It fired up, started running. Now at this point, I had no carburetor on there at all. This is just sucking straight through a T, straight into the motor. There's no regulation. So this thing's running wide open as fast as the motor will go. And I'm so excited about it. I shoot a video. It's out there. Actually, I'll go ahead and skip ahead a little bit. That's one of the videos after I'd cleaned it up and got a little further along. So about burned the generator up because it's running wide open. These things need to be governed. You know, they're not meant to spin the armatures as fast as I was running it. But I basically took a piece of aluminum. That's that piece you can see there. Threaded it, you know, so I could screw the close nipple in that's on the T. This line with the ball valves going down to the fumes. You can actually see the very tail end of that. It's out to the air. That's a blow-off valve. So in the event it does try to pre-ignite and blow back through the intake, that would let off that pressure instead of blowing all the way back through to the can and blowing the fuel can up. But yeah, it really is that simple. I threw the governor back on so it could regulate itself on the carburetor. So the carburetor is just working like a butterfly valve for the demand. And in this particular video, I've got a pair. You can use that. Oh, well, let's actually show up on the screen now.
You have to click right there.
Okay, cool. So, get out of here where I can see it. Yeah. Sorry, am I blocking anybody? You good? So down beneath the sawhorses here, there's a pair of heaters, like a regular little sunbeam heater you might have in some space, you know, bathroom or something in the house. Cold in the winter, fire up an extra little 1500 watt heater. So there's a pair of 1500 watt heaters down here at the bottom. one off of each leg off the generator. It's a 6 kW generator. It's running 3 kW of load. So I already know the specs on this thing from when I bought it new. It's a construction, commercial quality generator. It's not like a residential unit. It's meant to be out on job sites. And that thing says, we'll run 50% load, 10 hours on 5 gallons of fuel. And I've run enough fuel through it from ice outages in my area where I live, powering my house. But I know those numbers are accurate. And everything I found online about burning fumes in a generator, because the demand's so high and the mixture has to stay so rich, they say you only get 50% better. And I verified that. But hey, I get to run 15 hours instead of 10 hours. I'm cool with that. That's cool. The thing about the motors when you're going down the road, the difference being, this butterfly is really cracked open. It's got a lot of demand on it when there's a lot of load. So I get why the thing only gets 50% better, as opposed to, well, why is it so much better on a car versus a generator? Well, once you're up to speed and you're rolling down the highway, you only need like 20, 22 horsepower to maintain your speed, fighting the wind, going 60 with the cruise on. So the throttle plate on the motor in the car is really closed down. I mean, it's hardly cracked open compared to what this thing's got to do. So that's why the efficiencies look so different. So, I was kind of describing the thing I did with the generator about how does this work exactly. So, I mean, that really is all the components that there are. At a fuel can, it's one of these older fuel cans where it just had a nozzle stamp, with a cap on the end. I mean, anymore, you got these ones with the valves inside of them, they're spring loaded and they're only meant to try to put fuel in a car. It's not so easy to do this kind of thing. So, I mean, if you do have an older gas can around that has the plastic nozzle on it, all it did was just chop it off where it would fit the hose bar, so it'd make a good seal. That was it. I mean, as far as doing a, proof of concept or somebody want to do something easy, I've had people find this information out there on the website already, 100mpgmotors.com. And I got a phone call from a guy in Florida, and he's like, hey, I just switched my zero turn. He's got like a $6,000 mower. He's like, oh, I just flipped it over to run it on fumes, man. This is great. What can I do to my car? I'm like, pump your brakes, dude, easy. I'm not going to start telling you to do the same thing you did on the mower on the car, blow your car up and come up blaming me, So yeah, there's a lot of different safety things you take into effect, especially with the car that you don't worry too much about on a mower. But yeah, this thing does scale. It does work, and I'm all about technologies that scale. Part of what I didn't say in my introduction, I build Cisco systems networks for a living. So data networks, voice networks, Wi-Fi, mainframe. I've done everything Cisco produces. I'm my own consulting company, so I make stupid amounts of money telling people how to build networks. So my hobby has been, messing with Tesla coil-based things, not these high-firing things that we just seen. I build stuff that's on this really small scale, very low voltage, but produces ridiculous outputs, based on the same, theories and whatnot. But I'm going to try and stick to fumes on this particular talk. So I picked up this kit car. Wow, 13, 14 years ago now. And I've been sitting on it forever. I've not had an opportunity to build the thing. If it wasn't a money issue or a time problem or, not all the pieces are together yet, which motor am I going to use in the car and which transmission and all this business. Because I went at it kind of the same way I do my regular business. I've got this project plan, everything's kind of prefigured and all the math's been done. I know what I'm going to get when I get to the end of that thing. I'm not flying by the seat of my pants on that deal. It's a huge investment. So I picked this car up. I have gone through all those gyrations. Those things have happened. I've finally gotten to where I'm beginning to physically build the car. So if you do go to 100mpgmotors.com and look, there's a blog tab across the different tabs for the pages there. That blog tab is tied to 100mpgmotors.blogspot.com, but it's already tied in, so you don't have to go to the other. And in there, from this past February till now, is a real good timeline of all the progress that's been made on the car. And I've been really able to leap and bound whenever I do get time to work on the car. Because either family life or coming to events or, deploying networks for customers, what have you. But the times I do get to work on the car, because I've had all that other time while I'm away, I think about these things and I picture how things go together before I ever put them together. And I've built enough stuff already over the years. I know how things go together. So you can reason a lot of that stuff out in your head before you actually do it. So whenever I get there, there's no time wasted. I'll jump ahead. I'll watch other guys building their cars. So I'm part of another forum where guys are building these same things. And I'll see their progress over a time period. And they'll spend a little bit of time like every evening or every weekend or whatnot. And they'll just see me leapfrog in like a week. And they're like, what in the hell just happened, dude? How'd you get all this stuff done? It's like, well, I didn't show up at the shop and go, what am I going to do today? I went out there and got busy because I already knew what I was going to do. I knew where all the tools were. I knew where all the pieces were. If I had to fab something, cut it, weld it, whatever, I'd just knock it out. So I treat everything kind of that way, right, with the fumes and whatnot. So let me get back to that. The generator was first, and me, as soon as I know the answer to something, I'll leapfrog. I always have, And then I got people saying, what? You got a V8 running on fumes. It's just sitting there on the ground. There's like nothing there. I'm like, well, there's a battery, so I can fire it, and it's firing the coils. And there's the bubblers down there, and I'm holding the fumes line up to the intake so it can suck it in the motor. But yeah, I just said, screw it. I'm going to run a V8. I'm going to put it in the car. And I'm going to go down the road. They're like, dude, I'm just going to believe you. What do you got? A generator and then a V8. I was like, yeah. But, it's true. There's a lot of people I encountered, and they were like, yeah, whatever. There's no way. I'm like, well, you can come to the house, hit the starter button for me. I can't hold the tubes and hit the starter button at the top. So you can come crank it. You can look at it all you want, And I've had people come over and watch it fire and run, and they're beside themselves, especially if they bought into this can't happen, there's no such thing. Much like Stan's thing, right? It's like, oh, run a car on water, whatever, dude. So you're faced with that even with something like this, when it's really simple. So I went back. Okay, nobody's going to buy this. I'll go to the go-kart. So I've got one of these go-karts. Comes from Northern Tool. I think it were like $2,000 when I got it. It's a 150cc motor, fun kart. Full off-road suspension. That thing will like push over 2-inch size trees, saplings. You can just make a path wherever you want to go with this thing. It's ridiculous. So we've got places out there where we can ride this thing around near where we live. And you can see some strange hoses that aren't typical for that thing, right? So this is kind of this is my last stage of this thing. And it's been running like this for 2 years now. So anybody that wants to check out something that runs on fumes and go for a ride, I just throw them in the buggy. I'm like, okay, go. Check it out. You can see on this thing where the fuel line that comes down from the steel fuel tank, it's over here on this side under the fuel tank, and it drops right down to the carburetor. And that line has got, up there in the Carolinas where I live, it's just orange clay everywhere. I don't know if you guys are Clemson folks, but that orange color is for a reason. It's because that's the color of everything up there, So that orange clay, dirt daubers have filled up the holes where the fuel line's supposed to hook up. And the fuel line that actually goes back to the can, I'm like, okay, you can tell this thing's never had fuel in it like in forever. And then what they can see is I've got a small short line right there. It's super stubby. I extended it up and attached to this bar because they got to bouncing around too much, all that off-road riding. But what that is right there, it's a little tiny air filter. And it's the one like what you would see on like a 350 Chevy V8 that people put on the valve cover for a breather. So that's my air intake filter now. And then there is fuel in the steel fuel tank that belongs in it. And then the cap that screws on top, I just took one of those unibits, it's a big step bit, and ran my drill through it, knocked it out big enough to put a hose barb in it, and ran the hose off of it. It's attached to a ball valve right there, and it runs straight into a T, that same T that was on the generator. So I've got the air line that comes straight off the front. I passed it in between the front seats, so I can just hold my thumb over it for a choke, crank the cart up. It gets warmed up, I let off so it gets more air, and I take off down the road. That exhaust gas is blowing straight back onto this big baffle. There's some folded sheet metal right here. I attached drilled a couple of holes to attach some zip ties to it, to the bottom of the tank, so it warms the tank. I got it so hot in the summer, it got so rich, it killed the motor. And I'm like, okay guys, for the non-believers of you can't make power, what if you get a motor so rich you kill it? You gotta give it more air. You think you're getting enough fuel? Yeah. Yeah, this thing makes stupid power. It almost picks the front end up, you know, like you can go bouncing over stuff. So yeah, it's not got a problem making power. So, yeah, for folks that want to exchange information and go for a ride in the cart, you guys are welcome to come down. I always tell everybody, I don't care where they're from. You know, they'll be in the area, they're like, hey, so is the cart running? Oh yeah, we'll drag it out and fire it up. I don't care. We'll go ride in it. You know, if it's cold out, we'll splash a little extra gas in it because the raw fuel, you know, is reacting to the ambient temperature, and that fresh fuel will let the motor run long enough that that heated side will warm it up to the point that it'll run just fine after that. So it doesn't matter even if it's cold out. So these are some of the things that I've done. There's another V8. That is a Pontiac Trans Am, 1978, smoking a Bennett car. 6.6 liters, that's a lot of displacement. I had to take the cap off of the front of this 15-quart, this is like what you drain your oil into normally, right? Then cap it off, take it to the place, take the cap off, dump the oil. So I had these 2 half-inch air lines on top, a 1-inch line sucking out of the center of that. There's like an inch of fuel in there, there's like an inch of fuel over here. There's that yellow spout I was talking about with the hose barb on it. And then I was like, oh, how am I gonna get these air lines, these fumes lines, you know, because I'm sucking air on both of these cans, so that's all the air it's getting. I'm mixing air and fumes together, so I'm not gonna get a lot of RPM, but you don't need it at 400. It's a torque monster. $2,000, you're done. It'll go as fast as you want. But how am I gonna get this down through a carburetor? So I'm looking around, and I thought, well, I don't have one of these style, but I could run down to like AutoZone or whatever, grab one of these little 10-inch air cleaners. So I go grab one of those. This was the old kick plate on my front of the house. I had just got through replacing that. I'm like, oh, there's some sheet metal. So I just wrapped it in a band to fit that thing, drilled some holes, punched some rivets in it, got some electrical tape, taped over all the holes where that thing normally screws into your front door, taped up the can lids top and bottom, used the unibit again, punched holes big enough to pass those hoses into. Hey, got my son in the car, fired up, let's see if it'll run. And yeah, it fires right up, runs fine.
So you just set that on top of the carburetor?
Yeah. Yeah, and there's plenty of vacuum, so it sucks it down and everything makes a good seal. Now this car hasn't run since, God, when was the last time I was driving it? 01 probably. And the diaphragm and the fuel pump on the carburetor busts, and it leaks fuel and it won't run. I've had this happen like 4 or 5 times over the course of having this car. This was my first car when I was 18. It moved around the family, I got it back. So I had been driving it in 01. It had fired a couple of times, maybe, like just pouring gas down the carburetor to like move the car or something. But I hadn't been driving it on the road like forever, right? So this is, what is this? This is the summer of 2013. And this, you can barely see the corner of that jug right there. So that jug is for the coolant, and I can see there's coolant in it. Sweet. I don't open the cap and look down the radiator, but guess what? Somewhere this thing's leaked over time. I had no idea. I'm running this thing dry. I cooked this frickin' motor, having no idea, and that really, because this was the car, right? I'm like, well, I've got a blower cam I can stick in it. So I go out and I get a blower cam for it, so I can shut the exhaust before I open the intake. The most important thing in fumes, you have to shut the exhaust before you open the intake. So speaking about that for a second, the motors as we've seen them, and this is a 78 model, so it's definitely, you know, the most small ridden thing ever. Even though it's a 400, it only made 188 horse that year. It's terrible. That's how much smog control crap they put on these things and detune them and whatnot. But one of the worst things that they've done, doing a bit of history on fumes, way back in the day, 1912, when this guy got his patent, one of the first things that happened right after that, within a year I want to say, the chemist had been involved at the oil company saying, can't be having this. and lead was getting added, because all the fuel was unleaded before that happened. They added lead, it screwed up that guy's process, and then they felt a little sigh of relief. Of course, they figured out later with all the studies how bad lead was for everything in the environment that lives, and was like, oh, so now we're back to unleaded only. But now they're doing the additives and screwing around. Nevertheless, you can do the heat thing, and I can explain that in a second, because I have worked in oil refineries and petrochemical companies when I worked construction, so I understand how that stuff works. Prior life, before I started doing IT work. So, trying to remember what I was going to about the motor. So the blower cam. So if you got a turbo car or a blower car from the factory, there's stuff out there, right? Because they had these 3800 V6s. I'm going to pick on GM for a minute. They've had these 3800 V6 motors in tons of cars for a long span of years. It was a really solid motor. It was around during the Grand National days in the 80s, and it went all the way through, wow, early 2000s before I think they finally dropped it for a 3900. But that 3800 exists out there with a supercharger on it from the factory. It also exists as normally aspirated. So for the folks that don't even want to bother with, you know, I got to get this cam and this motor, you can buy the blower motor version of the car, you know, of that motor. I mean, they're around, they're cheap. You can get a regular version of that motor's intake and swap the intakes out. Now you got the blower cam and the motor, you've got one that you can throw the fumes to. Now you're going to look for, how do I meter the fuel? How can I adjust for normal driving and all this business? And that's where I'm going next. So, so this is my last bullet point right here. I've not been paying attention to time. What were we looking like time was?
No, we're good.
6. Okay. So, so the three typical methods that you find folks doing this stuff with fumes. One is the bubbler thing I was explaining, right? So that's what Frank's got over here. You're sucking air through a volume that has gasoline in it. You know, it's generating fumes off the top of that volume of fuel. You need to keep it warm and agitated, so it's constantly coming. Yeah, I mean this is the simplest form of it, right? So he's got. So this copper tube, is this what you're warming it with?
Actually, it's the outer black areas where.
Oh, okay, so he's warming the whole canister. I got you. So he's warming the whole canister, and this is a similar, from a design standpoint, this is very similar to what I'm going to do for line 2 computers. Yep.
I apologize for the interruption.
Cool. So this guy is
Sucking in the air.
yeah. So this is why you're keeping it agitated, right?
Right.
Yeah. So you're sucking the fumes off the top. This is allowing air to come back in. It's got tiny holes drilled into this line that runs inside there. Right. So he's keeping the fuel warm, agitated. He's got airflow through the box, which is going to equate to this. So this is good stuff to catch on to, right? As far as understanding this, I mean, look at the size of that hose compared to the size of that. So this is your restrictor for it's a mechanical means of handling. Well, how much fumes can I get demand-wise through a system like this? Well, this isn't variable. The thing that the demand's on the carburetor may be variable, but the limit that's going to stop it is going to be the size of that orifice right there. The cool thing is, for motors, there's a website, and I've got all the stuff available on the web. I'll pass out business cards to everybody that's interested in all this stuff and wants to read more about it. Or we can share information. If you guys have information you want to post up and not deal with machines, I've got an OpenStack cloud that'll spin up as many machines as we need. I think I can start up like 40 servers or something. So I got plenty of horsepower to start up whatever we want. And enough disks to store probably everything you've ever downloaded that you want to see again on any of these topics. All right.
Keep going.
Okay. I guess that was the don't worry about it. Yeah, the thing you told me, he's probably like, don't worry about it. Okay, cool. So yeah, any of those resources that you need, if you want to have encrypted communications, so that you can actually have a private conversation, Edward Snowden finally let everybody in on that there is no such thing. Yeah, there is a way, and it's very difficult to truly ensure that you have a private conversation. There's another way that makes it a pain in the ass on them. They can get it eventually, but I can talk about that tomorrow. So on the fumes thing. So the orifice size, that's what I was getting to. So for this size airline to pass, how much fumes and how much air can pass through that, there's a good equation available out there on the web. I've got links to it that lets you put in the number of cylinders, what's the bore and stroke, what's the RPM. It doesn't say fuel. I believe it has something about the horsepower. So between those different input variables, it will come back and tell you the orifice size you need, how big a pipe do you have to suck air and fuel through to allow this size motor to run this many RPM. So that's a handy piece of information to know. So once you know these things, you can go back and do all the math. Well, there's another spreadsheet out there that I had found from some Mustang guys that drag race their cars all the time. They've got this thing where you can put in the tire size, your gear ratios in transmission, your rear gear, and it'll come back and say, oh, your motor's going to turn this many RPMs in this gear at this speed. Awesome. So now I can even calculate all the way down to my miles per gallon before I even crank the car. So I've done all this math already, and the simpleton version of doing the fumes, which I haven't got to that third process yet, and that's the one I'm going to start with, which is past simpleton, but it's better than the bubbler. But it's not the best way that you can do just fumes, gasoline only. In that math, it says I should get 160 miles per gallon, 130 to 160, depending on how lead-footed I am. But the things I've talked with Frank about since then, and knowing that I'm not actually going to do that version, I am going to run the heated version of it, it should exceed 200, no problem. And a lot of that information is going to be able to be taken from that orifice size business, right? Because if I only need, let's say I allow it to give me 100 horse out of 300 horse it could possibly make. I'm restricting it down so far that I'm mechanically holding it back from an air-fuel ratio of so much. You can't help but get good gas mileage because you're not sucking that much fuel because you're not allowing the demand. Now, a word on fuel computers. As things have been since late 80s, early 90s, fuel computers have allowed a variance for control by the O2 sensor, saying if it's rich or it's lean, and the fuel injectors can pull back or they can dump more fuel. And it's trying to maintain what they claim that car's supposed to get. Because it's interesting, right, how over the years you see different cars getting released at different times, and sometimes they have ridiculously good gas mileage, and we go through a period of 15, 20 years, and it's crap, and then all of a sudden it's really good again. And you see these laws coming out that say, well, you have to put out at least this many cars, of all the cars you're making, they have to do at least 35 miles per gallon. And once they start enforcing these things, then you see it start coming back the other way. Gas mileage starts getting better. It's like, okay, so what are they doing? Well, they are literally, and it's on C-SPAN, you can see it on YouTube, or it's been recorded from C-SPAN, they literally work hand in hand together. The guys that are making the fuels, and the guys that are making the motors, are ensuring these things jive together, and they are behaving as engineered and expected. For example, I had a 90 model Corvette ZR1 for a period of time. That thing made 400 horse at the wheels, and it got 29 miles per gallon down the highway. To me, that's like the new standard, you know? If you're going to have a high horse motor, it should get at least 29. But directly following that, the Corvette Sense, no such animal. They're just now coming back to like 28. And it's a completely different motor. So it's not like they can't do it, right? So what we're going to do about this, because the computer will allow a variance, but once you go too far outside of the bands of what it's going to allow, its default method is to assume something's broken and it falls back to this backup mode they talk about, right? Where it only works off of a handful of sensors. It doesn't try to maximize economy anymore, and it's in what they call limp mode, so you can get it back to the dealership, check engine lights lit, you know, you got to go get it checked out and see what's going on. So it is a way to ensure that it does perform as designed, but it's also making sure that you're not trying to drive it outside of that zone. Because folks that add HHO to the intake, or they do things to drive better gas mileage, it eventually pushes the O2 sensor so far. And initially, you get that 20 to 25% better gas mileage, but then they say, oh, then it gets worse after that. And I started dumping even more hydrogen to it, and it got even worse. Well, yeah, because you blew beyond its window. It's allowing you 20 to 25%, but once you blow beyond that window, values are out of range. Computer's like, and it goes into backup mode and it starts dumping more fuel again. So, what do you do about that? Well, you lie to the computer. You get rid of the O2 sensor. You put in an O2 simulator. The O2 simulator tells the computer, O2 is great, it's perfect, stoichiometric all the time. Doesn't matter what the RPM is, doesn't matter what all this is, you're on the money. You're firing exactly right. And all that's doing is making the fuel computer run off of its maps it has. It knows these inputs at these RPMs should pulse the fuel injector this amount. That's all it knows. So that's what it's doing. As those variables change, it adjusts the pulse rate accordingly. So if we start lying to the computer and we start replacing it with other parts, so I don't want to run my fumes motor lean and burn a piston up. So what am I going to do? Replace the O2 sensor. Exhaust gas temperature. EGT will tell you if you're running lean or rich. It's in every piston engine aircraft I've ever seen. Works great. So in my second from the front and most rear cylinder, I'll have EGTs in, and I can get an average overall of the length of the intake runner. And I can see where the motor is temperature-wise. I know if it's rich or lean, and I bias that O2 simulator to let him tell the computer if he's rich or lean, and I switch off all the injectors. I have a couple of relays. It's going to switch them off into dummy loads, because if the computer doesn't see the injectors, it says, shut off the fuel pump. I can't fire the injectors. So if you switch it into a dummy load, now it's...
So that click spacebar.
Gotcha. And I might have restarted. Yeah. So so I switched the computer's connections it was into the fuel injectors themselves into dummy loads, so that it still thinks it's firing injectors. I listen to the number one injector, and I use that pulse, because that computer and that car and that motor were designed to run together at that pulse rate for this size motor, this displacement, this RPM. I don't have to work all that out. It's already in the car. I'm not going to reinvent the wheel. I am going to get an Arduino, little hardware controller computer, and I'm going to have a Raspberry Pi, another small Linux-based computer, and the Arduino is going to take a handful of inputs that is going to mirror what the car's computer sees. I want to see them too in the raw, and I'm not going to work through the data bus and pull them from the computer and all that business, because every car you go through, you have to deal with the differences and whatnot. So the Arduino is going to learn from those same sensors the car does, and the Raspberry Pi is just going to be your display that's in the cockpit. I'm flying all the time when I'm driving. So up front though, I'm going to have a little touch screen in there, and it'll give me some of the numbers that I need to know about what's going on. My EGTs are going to be on the A-pillar in the car, right beside the windshield, the frame by the door. So I'll have my temperatures there. I can see the computer's going to see those temperatures. He'll be driving the thing. Single injector instead of 8 injectors, it's a V8. So you can kind of tell what the math is going to work out on that right away. So that's going to be what I'm going to call Fumes 1.0, right? And I don't have this all drawn up to show, but basically what it amounts to, those handful of sensors I'm going to read in parallel, switch injectors off. Excuse me. I'm going to have a chamber, but it's actually going to look more like a little box, kind of a section thing. And inside of it, it'll look kind of like a little oil cooler or a small radiator looking thing. It's all welded aluminum. It's going to suck exhaust gas straight off the exhaust. It's going to roll through this box, probably slightly cool at first. It's going to suck it through the box and back around to the intake, and I'm going to valve the how much heat it's pulling through that box based on the fuel. That's one of the things on the touch screen. You're going to tell it which kind of fuel did you put in the tank. Because this thing, now you run on fumes, you become multi-fuel. You can mix all kinds of stuff and run. So different fuels are going to have those different temperature flash points, and you're going to not want that box to get too hot, pre-ignite the fuel before you can get it to the motor. So that's going to be a component. Sorry, go.
You can use a liquid intercooler.
Yeah.
It's already set to basically be exactly that, except
Yep.
it's full of hot, and it's already got the spaces. A lot of people have them that come with temperature sensors on them, so they know exactly what kind of boost they're going to get.
Right.
That's already.
If you know of a cheap one, let me know, because the last one I had was $1,100, and I'm not spending that again on
I
another.
have a friend who shoots them, and he sells them for like $200.
Sweet. We're talking. I mean, because that's literally part of the pathway, right? And whenever and what's the end goal with this thing, you know, and all that, I'm giving away like all the information. Yeah, I'm gonna give it all away. Because I know not everybody's gonna go out there and build their own. They're gonna say, no, I want that dude to build mine. He had all this other stuff going and whatnot, so I'm not concerned about that. That'll come. My concern is finding the folks that wanna do it with me so that they can actually build it, because I'm busy doing other crap. This is a stepping stone for me. This is like low-hanging fruit. I'm like, yeah, this is simple. I can get on it right away. I can get it knocked out in a couple of years' time. Once I'm there and that kit's built, what's that kit gonna be? I've got a guy that builds wiring harnesses for cars. He's actually very well known in sports car circles. He is the guy to go to if you want a Corvette motor put in your RX-7. He's one of my buddies. So he builds wiring harnesses for interfacing completely foreign things to one another, and they all plug and play. Everything works just like it was supposed to from the factory. All the gauges are good, the AC kicks on like it's supposed to, everything. So this isn't little Mickey Mouse weird, you know, hope it works stuff. Pins everything out with, you know, same connectors that the guys use from the manufacturers. So I've got that guy. 2 streets over, I've got a guy with a dyno. He wants to see a Fumes car on a dyno pulling real power numbers. He doesn't buy into it'll make power. No problem. I get free dyno time out of you. Awesome. Thanks, dude. I'm on that. There's a racetrack about 5 miles as the crows fly from me. Dale Earnhardt and his son used to come down there before NASCAR season every year and run their circle track car to get it ready and dialed in. So, you know, it's one of those things of networking with people. You know, I know these guys, they know somebody, they'll let me on the track. And the point being, build a kit, modify the kit where it works with that particular motor. That'll be the first motor I'll release it for. Hey, anybody want to go grab one of these out of the junkyard and throw this on it? There you go. Other motor releases will come later as we start doing that, you know, for V6s and inline 4s and what have you. I'm working with what I got. I got a V8, that's what I'm doing first. ROFLU, all the stuff we can do ahead of time to get the math as right as we can do it before we actually roll it out, get it to the dyno, tune things there, make sure they behave as we expect, go to the track, you know, set the thing on 60 mile an hour and just let it run for 4 hours or what have you, consumption test, gather all the data, all the stuff will be data logged. It's the point in having the Arduino on the Raspberry Pi. The Pi will be the interface for the car, but it's also Wi-Fi, and it'll talk to your laptop in the car and dump all the data that you can stand. You know, for the people that need the verification or want to build their own and they want to see, oh, well, that's what this takes, you know, I can tweak mine this way, thanks, dude, you know, they can move on. So that's what the kit's going to be about. An electronics bundle, the 2 computers that are pre-programmed to do this work, the EGTs. It's going to be like basically a bundle of stuff with the vaporizer box, but I'm not going to plumb the intake and the exhaust side to the particular motor that you're trying to do it to. And I think, I don't know, but I have heard of folks building kits that are very similar to the other things that are already out there, and they say, hey, you're infringing on this patent and what have you, and that kind of deal, right? So, and I know it doesn't matter that I've got prior works before this particular patent came along, but after I whiteboarded this with multiple people and had drawings, it wasn't a year later there was a patent that looked exactly like my thing. So I'm like, bastards. That's tomorrow's talk, how that happens. Because I do know firsthand about how those things happen. I've had clearances, I've built secure networks for alphabet soup and military, and yeah, I know how those things happen. So, yeah, that's the majority of what I've got for the Fumes. Started one day, I seen a video, ran out, grabbed a list of hardware from Geek Page, ran to Lowe's, got that stuff, came back, plugged it on the front of this generator, second pull, fired right up. Had multiple people come by and check it out. You know, I told some of my buddies, and they know I've looked into this stuff since, you know, early 2000s. And you know, it's kind of funny because for different people, it's different stuff, you know, that does it for them where they go, ah, that's real. And it's weird, right? Like this one guy, I would treat him like a brother. And he came over and I had the generator out in the garage, it was cold out, and I told him, you know, it might not start first pull, it's cold, but we'll see what it does. first pull, it fired right up. And he's like, oh, that's it? I was like, well, yeah, what'd you expect? Well, you'd have to tinker with this and tweak that and do this thing because, you don't exactly know how it works, and maybe it doesn't always work. And I'm like, dude, you get in your car and you crank it and it fires right up, right? It's been engineered, hasn't it? It's the same thing. If you know the flows and the volumes, and it's math, dude. It works. So that was it for him. The guy down the road, lives down the road from me, he built all kinds of stuff. He's got a 57 model passenger bus. He's converted into an RV. Really nice. Teak wood and stainless steel inside. It's like a yacht. It's like, holy crap, dude. The guy works with his hands all the time. He comes down, he's built motors and stuff, tinkers on dirt bikes. He had a Fiero, and this is a Fiero-based kit car. And so he wanted to come down and check it out. And I said, hey, you see this motor? Turn on fumes. And yeah, that's probably Nate there in that picture, cranking that one. But I had him come over and hit the starter for me, dude, so I can hold this thing up there and we'll fire this thing up. He hits the starter and he's totally inspecting everywhere. He's looking for a way this thing should be running. And I specifically got these lines. They're clear with a fiber reinforcement, just so people can see. You don't see any trailing liquid racing up through there. It's just dry fumes. So they can see that, and the guy watched it and he just shook his head in disbelief. He was in total denial the whole time. And for another 15 minutes after he seen it happen, there's no water pump on the front of this thing. So I only let it run 30 seconds. I gotta kill it. I'm not gonna cook this motor too. I was just lost the other motor. So he's beside himself. He just couldn't believe it. And then during the course of the conversation, I said, well, if you look at my webpage, the very first, the home page that he hit, it's got a little bit of a history lesson on there. It's got a couple of links where Smokey Unit did this in the 80s. And for anybody that's a race car buff and fan about NASCAR and whatnot, Smokey Unit was amazing back in the day on the things he did. He was one of those guys that was an engineer and a driver. He wasn't one or the other. He was definitely both. And he won races. And he come up with some pretty interesting cheats. But once he's seen how to do this, he did this to a Fiero back then. 84, I want to say it was. And it was the Iron Duke 4-cylinder. And he got 63 miles to the gallon and 0 to 60 in 5 seconds, which was fast for a 4-speed that you had to shift, and the synchros were crap. You couldn't shift fast, so it's not bad. He had a 3.8 liter V6 that didn't have one of the heads on it with a big, huge, flat piece of steel bolted down where the head belongs, and he balanced out the thing so it was only a 3-cylinder, and he had this weird way he would plumb up a turbo on these things to behave where the exhaust ran. It was not like you see a turbo normally plumbed. He would run it through, it would do some warming. He made it work like a reactor. He brought it back through the intake side to cool it enough before it went into the intake. It was strange. It's on Hot Rod magazine websites, and the links are on my webpage. So you can go straight to those articles where they describe it, they show the pictures and whatnot, what he was doing. But he did some interesting stuff with the turbos. But now we're getting back to that thing I was talking about, flows, orifice size. So he traded miles per gallon for performance because he wanted a little of both. I can't imagine what that 4-cylinder would have been if he would have necked it down and stopped it from getting wicked performance and let it maximize the gas mileage.
Just to back up on the warming of the fuel, if you're in a cold climate, snow, 32 or below, are you going to need some type of a
Preheat it somehow or something?
Or just crank it and then it'll
So,
warm itself?
Yeah, I live in the south, so the coldest, we have ice down there and whatnot, but still it's nothing like living up north. So I'm sure my initial stuff that I'm going to do is going to be spraying enough fuel. So design-wise, I knew I was going to wind up on the whiteboard. Thanks for this.
I was trying to get you over there.
Because I'll wind up talking with my hands. You got?
I can hold it.
No, I'm looking for
Marker.
Yeah, the easel was right up here earlier. There it is over there.
It's on the other side of the building. On the paper towel.
Yeah, right on the computer, right in front of you, Frank. Yep.
Awesome. Yeah, I guess head on out. I'll go back out.
Yes.
I might So I got a good spot for most. Hopefully it doesn't fall. There's a live layer on that whiteboard. I don't know if it would have to be like that, so yeah, it's just gonna be bad. So a quick rundown of what this thing's gonna look like. I'm trying to decide if, because I got more room to draw vertically. All right, so we'll have air coming in. It hits the vaporizer box. Right, this is the intercooler looking thing we were talking about earlier. So it looks like kind of like a radiator inside there. All right, so basically what I'm trying to draw is this line is representing air running back into the intake on the motor. This is coming off of the exhaust so you can get heat through that guy.
Okay.
So this will be my fuel injector. I'm going to spray fuel. It's going to be at the right distance. I'm going to have to like measure it out in the air so I can see the mist, because I want it to mist out as much as I can right as it's coming in contact with the plate. You guys see it? Because it's going to get messier as I go, so it's going to be harder to understand later.
This is for a cold start circuit?
No, this is like normal run. So it should be wet enough on cold start, like the fuel injector will probably do like double time, like spray double what it normally would to enrich this guy enough that it'll crank. Because even when you don't have a lot of temperature to work with, you can do what the guys have been doing from the car factories for years, dump more fuel on it. I mean, literally.
You're injecting fuel back in your fume box?
Yeah, back
For
here.
starting?
Yeah, it's the only injector that's going to
Or
run.
different fuel?
I'm going to run off the same fuel pump, same fuel rail. I'm going to use the same fuel pressure regulator. I'm just going to tee off of that line and run up here and run this other injector, because I'm going to switch those injectors off by pulling the power away from it. So, and that's another thing. If you do screw around with this on an engine stand like I had, you got to go down through there and disconnect all the fuel injectors, because if you dry fire those, they're not going to last long. So my original thought back when I was first doing this was, well, I'll let the computer allow the injectors to fire normally, crank the motor, and then after it hits 100 degrees on the water jacket, then I'll switch the injectors off and let the fumes take over. But since then, I've seen enough off the single injector business that I'm like, yeah, screw that. Now, that's still an option, of course, that the computer could do an outside temperature, and I'm going to have outside air temperature to know, because of having to do with when you lift throttle and you're going down a hill and keep things from backfiring and all that. There's a lot of drivability stuff you have to learn about these things when you go down this road. But anyhow, I've done a lot of reading. So yeah, as long as it's warm enough, you should be able to fire the one injector. It'll crank like normal. There's no need to fire these first. I could always have that be such, whenever I discover what that temperature is too. I don't know what it's going to be. But yeah, I'm sure there's a threshold. Definitely 20 degrees, I doubt that would work. I'm thinking you fire the car normally, and then when the water jacket hits 100, then you turn on.
Just a dinky little vacuum carburetor thing. I've got it to start up in freezing. It's just, it does not last at all. So it might be enough if you're going off the exhaust or something.
Yeah, it'll be pulling exhaust right away, and exhaust temperature will still take. Yeah, but it'd have to run a minute and a half at least.
Exactly.
so it's not gonna happen if it lasts 10, 30 seconds and dies. I mean, that's not gonna do it. And the reason I said just dump more fuel, Volvo is one of the most common cold start fuel injectors that all the performance guys like to grab, because they'll run normal car fuel injection. They'll get the one from Volvo, and in theirs, they've got right behind your throttle plate where you push the gas, and it opens up the throttle plate going into the motor. Right behind that, even though it's got normal fuel injection, right behind here, there's this like huge honking fuel injector that just sprays stupid amounts of fuel on its cold start circuit. And people go and grab those so they can dump more fuel because they're sucking more air, or they're adding a turbo that doesn't belong on their motor originally, or what have you. And instead of going out and getting bigger injectors, and beefing everything up like they should, that's the cheap way of doing it. They'll go out there and get one of those and just dump tons of fuel. So I know I can get away with doing that kind of stuff for a cold start, but as the car sits right now, it's not a drivable chassis. The axles are getting produced right now, actually. I just got those sent off a week and a bit ago. So before Christmas, I'll have axles for the car. And the reason all this is custom stuff, the motor is out of my 95 Trans Am whenever I had it. It made 530 horse at the wheels when that motor was in that car. It was under 12 pounds of boost. So the supercharger's out. It's back to normally aspirated. It's probably about 300 at the wheels now. But that's fine. I'll take 300 and 200 miles per gallon. That's cool. So that's the motor. The transmission's actually out of a G6, a Pontiac G6, because it's a 6-speed manual. And those axles that run from that are meant to turn hubs for a G6, not for an S10. So the front wheel drive part of a S10 4x4 Blazer, that's what my rear hubs are. So now I've got to come up with a custom axle that has a G6 output that turns S10 hubs. And then of course I want the axle to be strong to handle 300 horse, so it's off at this shop getting made. So yeah, there's some things that are ridiculously expensive that I'm not cutting corners on. There's other stuff I don't care. This is a mule. Yeah, it's a Lamborghini Diablo kit car, but I'm not going to go for, it looks exactly like one perfectly, because the initial shock of seeing it in the first place throws most people off that don't know any better about the differences between the real thing. I'm not going overboard on the whole looks thing. This is what I want to do. And I want the car to bring the attention, so people see the Lambo, they're like, oh cool, look, the door goes up, I want to take pictures of it. 160 miles per gallon, what the hell? Conversation ensues, right?
Wow, that car looks crazy.
Right. So that's the idea for what I'm calling Fumes 1.0. It's going to, heat this unit up, blow the fuel across there, suck the fuel in, should get a complete burn. And the other thing I will go to, my state doesn't require an inspection.
What's the temperature of the heating device?
It depends on the fuel. So you select which fuel it is,
Cracking the fuel,
and then you
or
know
you're heating
heating it.
it. You can crack it, because you're gonna crack the additives too.
Yeah, I've not really decided what I'm going to do about all that. I know,
I run a small engine right off a hot plate.
right? So, and that's what I'm getting at. I don't know what kind of buildup of crap I'm going to get off the additives and how long that's going to take to happen. But you'll hear what my Fumes 2.0 thing is next. So part of the reason I'm not overly concerned about that, I only plan on driving in this mode for about a year, maybe 2. My Fumes 2.0 thing that I want to do, after this is done, it's been on the dyno, it's been on the track, I'm going to do the Lap of America thing, go see all my buddies I haven't seen in years and prove that it works, and Ustream from hotspotting on my phone in the car. Here goes the car down the road, everybody keep up with me while I go. But I'm going to do a Lap of America in it. Once that's done, I'm going to come back around here. By then, I'm thinking it's a couple of years from now, Max and I are going to talk about hydrogen, and my idea to take that to the next level is the fuel computer's back in control again, but now he's controlling, he's watching not just what this ought to be, but he's going to start watching this pulse rate, where I'm watching cylinder number 1's pulse rate to know how often to pulse that injector and bias it based on rich and lean. I'm going to watch something else now because I'm going to inject hydrogen in. And now I'm going to be watching the map sensor for the demand, the RPM, and the throttle position to see what the demand's trying to be. And now I'm going to start swinging back and forth between how hydrogen enriched that burn is. And if I'm rolling down the road and the throttle plate's damn near closed and I'm under $2,000 on the tack and it's a joke, then it's almost going to be pure hydrogen. It's going to be very little fume burn. And then how am I going to do that over here? Well, I'm going to take that pulse rate and I'm going to use binary and I'm gonna divide it down. So initially it's 1-to-1. When the pulse rate says fire, it's firing. And then as it rolls off and starts to sweep into more hydrogen, for every 2 pulses, I pulse once. Then for every 4 pulses, I pulse once. 8 pulses, I pulse once. That's how I'm gonna control it and let it stair step like that. And because the rest of the software is gonna
Because once you're
smooth
going,
out
you're
the
not
steps
gonna
in
need a
between.
pulse every pulse. You know,
Right,
just
right.
like a swing, just now
Right.
and again.
And it changes the B2 enrichment, you know, and it keeps the injector on, you know, everything still runs, it's just not as much fuel. So, I mean, if you are in a panic situation and you stomp it and you need to get the hell out of the way, it'll come on. There's not gonna be any hesitation for that. Because all of the sampling that's going on and when it actually happens, it's gonna be less than 100 milliseconds. So it's gonna be fast. So Stefan, does that help? Is that data only stuff for you, man? You digging that? So we were talking earlier. He's like, I want to see all the data, man. So that's the plan for that motor. It was a bear getting it into the car, literally. I had to cut a chunk of my frame like this long out of the right side of the car. It's gone right now to get the motor in, but now that's in, I'll come back and weld around the motor to put the rigidity back in there. But as it was already, it was really beefed up way beyond the factory, so I'm not overly concerned anyway, honestly. But yeah, I'm going to tie the metal back together in those 2 points because it is a stressed spot. It's just not stressed as much as it was from the factory. Whenever you cut one of these cars down and you set one of those kind of bodies on it, you actually go back with more steel out around places where it didn't used to exist before. So there's all kinds of triangles and extra steel around things back to the rear suspension and around where the motor is. So the car's plenty strong. I'm not worried about it, but I'm not going to leave a gaping hole there either. But yeah, that's the idea. That's the plan. So any more questions? Anything? I mean, does that sound groovy? What I'm talking about doing there about swinging between the hydrogen and the
Are you
fuel?
dealing with how are you dealing with the advanced timing? Is it electronically controlled or?
It is. It's electronically controlled. So once again, a lot of the computer.
Computer
pul-
wants, if you
the
lean
pulse-
out the fuel, I've run down a road and I laid up my fuel injectors without any HHO, without any vaporizer.
Yeah.
And just punching it, and there was no knock, because it was retarding the timing off the knock sensor.
Right.
To be able to control the advanced timings. That's what everybody's problem is.
Really?
Uh-huh. I was going down 70 miles an hour, and I leaned off the amp sensor.
No, I'm saying electronically they're having a problem with that because you go in line and you interrupt and you lie to it. So you take the pulses in and you don't let them go straight to the computer for the timing. So you take the pulses in, you count them, and you do what you want to do with it.
But how are you controlling the advanced timings? You gotta be able to roll.
You delay. Yeah, digital delay. So from the pulse rate you're getting in from the timing, you can retard or advance what that timing is that you're putting out on your side. But yeah, you get in line of
Are you doing it
that.
on the fly, or are you flashing the computer?
No, I'm leaving the stock computer in. I have my own computer that lies to the stock computer. People have been doing this for years where they'll
But are you
piggyback.
dialing a knob? It's
The
like
computer does it for it.
Like if you were to brake torque it at 2,000 RPMs and dial a knob, can you make it knock and then turn off the knock, make it knock, turn off the knock?
You can, yeah.
You can?
Yeah, I mean, I'm not doing that right this minute, but
No,
yeah,
but you
I know
can
how to do
control.
that, yeah.
Okay. Because that's the biggest hurdle right there.
Okay. So,
So
Yeah.
what's the hurdle with the carburetor system on a car when you, like you said, you got someone who can't drive, you just want to get out of there now?
oh, and it's
Back off.
carbureted, and
Yeah.
you're trying to do this thing up in front of the carburetor?
When you're trying to just run on fumes, yeah. Or do you run into that problem? Is it,
Well, I was gonna say, so on that one, you got a mechanical distributor that's got vacuum advance. So now you literally have to get into the vacuum and play man in the middle on that thing. Or remove the vacuum advance and put in your own vacuum that's controlled electronically. You could do that.
That seems to be the best way, because I have a simple system on the motorcycle, and if I were to just floor it, I'm instantly running way too rich, and I gotta also open up 2 different air intakes and take my hands off of the handle.
Yeah, he's totally analog. There's no digital nothing on that deal.
But everything he's saying is what I'm doing analog, which is super hard as shit to do.
Right, and that's why you want a computer to do it, because
That's
then you can
exactly
order
why
that crap.
what you're doing will work.
Right,
So I've got it to work with my hands, it's just
right,
hard.
right.
But
So, just a word about that. So on my particular setup, this is an LT1 that was in the mid-90s and early 90s in the Corvette. That motor has a thing on the front of it called the OptiSpark. It has 4 different slots for crank position. Each of those slots, it's basically firing lights through slotted wheels.
Right.
And on that thing, the 4 different slots are 4 different sizes. They're like 11, 15, 17, and 19 degrees, I believe, per slot there. And then it's got 1 slot per degree, 360 degrees for the cam timing. So it knows exactly where the cam and crank are within a degree at all times. That's why it starts so fast. When you bump a LT1 over to crank it, you hardly hear the starter, it's running. And that's why, because not only does it know the crank position, it knows every 90-degree interval of the crank position. And inside of those 90s, it knows the counts off the cam. So it knows exactly where things are. It can fire the first cylinder that's available.
Right.
Instead of, older stuff, it turns over a couple of times before it finally hits the cylinder. Because it's trying to discover the timing. So what I'm getting to about that is I've got separate high energy side. That OptiSpark unit is the sensor and the coil and the distribution all in one little flat pack unit. Those things were notorious for burning up because of the gap. I mean, the thing's not an inch thick. It's flat. It's in behind the water pump. I mean, it gets heat soaked. You got 20,000 plus volts going through it. If you're running a car $5 grand down the highway, because I took it to Europe and I drove it on the Autobahn like 150 miles an hour, set the cruise, took my foot off the gas and steered for it. It was pretty cool. But you keep the motor wound up like that all day, all that stuff's getting hot and it starts failing. So you take all that high voltage stuff away from it, you leave the cam sensor and then crank sensor, angle sensor in there, and you give it to DIS system. It uses the wasted spark like Cadillacs did and all that. I've got a 4-coil system on this motor now, which actually I think we can see in that picture.
Yeah, where he's pressing the crank it.
Yeah, we could actually see it there, couldn't we?
It'll just take a second.
So right through there, those labels that are at an angle, there's 1, 2, 3, and the 4th one's back there at the back, and there's some cable wiring harness coming across the top. But yeah, that's the coil. That's the coils. There's some plug wires going over top there. Plug wires coming down this way. And then all these reds, these are just the 12 volts that are needed to wake the computer up, power the sensors for spark, power the DIS so it can give a spark. It's like 5 wires. That's all you need on the motor. So if you really wanted to get into the hobbyist, I'm going to do it myself thing, you only have to have fire wires on that computer. It'll fire the motor, it just won't do any fuel. Because you're not running the fuel pump at that point. But if you do just a bubbler like I'm doing there, I mean, that's all you need. Hook 5 wires up so it can get spark, get some fumes on the front, blow a little heat by the bubbler so it keeps going. I mean, for a proof of concept, somebody wants to screw around quick on a V8, it's that simple. So, yeah, I've separated that out. So I've already broken that out, right? So now I'm taking the ignition's spark timings, and it's already got a T built into it. And one part of it goes off to the fuel computer, the other part goes into this ignition module on this coil pack. So this guy is already breaking in line on spark. So yeah, what do I need to do? I'll make another T. And where it's on its way to the fuel computer, I'll just hop in there with my T so I can break that connection and lie to it and send it from my Arduino instead and pulse the motor or whatever I say the timing is. That'll be the end of that, yeah. Yeah, I'll listen to it and I'll either relay it on or I'll be like, crap, I gotta dial back. And that's what I'm getting at on the Fumes 2.0 part, right? I don't have to worry about that much on the gasoline side. As soon as I start hydrogen enriching to the point that it's really taking over and it's starting to affect the timing, then yeah, that'll be my next thing I'll go tackle. Will be, yeah, I'll plug in line and I'll start dealing with that. But it'll be the same thing, right? That Arduino already has the smarts in him. He already knows the RPM, the map sensor, the throttle position sensor, the temperature, and coolant to know if he's in a cold start mode or not. So that'll be the 5 sensors I'll need. And I'll hear and then I'll add that 6th one, and it'll be the timing. And I'll say, oh, okay, well now I'm getting this. The fuel says this, and the fuel's going to be that variable that's sweeping in between those two. So that's why I want a computer to run it, because I definitely don't want that nightmare. Holy crap. I can't imagine trying to deal with, well, the fuel is constantly variable, and your temperature of this thing's constantly variable, and the conditions are, holy crap, dude. Yeah, no. Here's an 8-bit computer. Here's all the code. Here's a truth table. This is the inputs. These line up. Here's the output. Right. Knock yourself out and let it go. Let it do it. Yeah. And I've got buddies. I'm not doing it all by myself. I got a microcontroller guy. I know enough about microcontrollers, but I got a microcontroller guy who's going to help out. Got the wiring harness guy who's going to help out. Got fabrication guys that can help, fab up anything I need to fab up. I definitely want to do the intercooler thing because I want to take something that's already out there. I don't want to reinvent the wheel on that. Yeah. And it's nice because the intercooler I had that was actually on this motor when it was supercharged set back at an angle. So the unit was like this. The air came in and turned and went through the unit and then came back out. So that's awesome because now all I need is a couple of 90s or straight shot this way. So I can have a unit here that has the fuel injector on it, sprays back up in there, so it'll hit that wide area. Because that one had a lot of surface area in it.
Now that you're going to be hurting for efficiency, you want to avoid 90s, but
yeah,
you're not hurting for it, so you
right.
don't have to.
Well, and then, so another thing I've been picturing in my head for a couple of months now, how to deal with, when I was talking about this orifice size business and restricting the motor mechanically so you can't overdo it or what have you, one of the things I've been considering is, and I only know about it through labs, people that have really expensive, nice labs, like the government. I know those guys have them, universities. But they've got these apertures that you can get that are variable iris. It's kind of like the iris on a camera, where it'll close down. It's a big spiral looking job. They've got those that are made out of some ridiculous materials. They won't cave under vacuum, and you could have those things
choke it down.
Choke it down, right? And one of those things I'm going to be all about. If I ever have to get out of this car, let somebody park it. I want that thing neck down to like 1 inch.
Yeah.
Valet parking. Yeah, screw that, dude. You're not going around the corner and punching it and dumping the clutch and spinning the tires. No. These things are 335, 30, 18s. 13-inch tires out back. They're expensive. No, you're not going to go turn my tires. I've even considered, and I'm very much against all this RFID chipping people crap, but if I get my own, I write my own code in it. I know what's on that bastard. I've considered that because you can put an RFID reader in the door so nobody's paying attention when you're cranking it, that your hand happens to be next to the door, and then nobody's going to crank it unless I'm present. Or they take my hand and put it up there.
I was going to ask about how long, do you know how long people have been doing this for in terms of using vapor as a way to power an engine?
Documented since 1910.
Wow. And
1910, there's actually a lot of electric cars on the roads in the cities. Delivery trucks. It was rampant with the electric cars. But yeah, 1910 was the death of it. 1912, it was a joke. Electric cars.
What was the source?
Who wants those old batteries? Right. Yeah, if we worked on batteries since then, holy crap.
What was the source for that? Do you remember where you got that
from? Well, through the patent search, you can see where the guys applied and accepted in 12. You can see whenever his work was done and the patent was applied for.
Do you know names off the top of your head or anything? If someone wanted to find it, that's what.
Yeah, I would just say hit that 100mpgmotors.com and
perfect,
because it's got it's got links in it to some of the history, and I can always go in there and bump that up.
Awesome, thank you.
Yep.
In your research, have you ever come across the book? It's out of print now, but it's written by the Shell Oil Company called "The Fuel Economy of the Gasoline Engine"?
Yeah, you know about the. Have you seen the video where the guy that worked for Shell was on his deathbed and he's talking about the gas mileage that they were getting in their labs where they were screwing around in their friendly competition?
Yeah, I saw that.
Yeah. Yeah, it's like 73 when the big OPEC scare happened.
Hot coolant to boil the gas.
Yeah, they did a lot of things.
Yeah, because you can actually gas boils with if you run 190 degrees coolant from the radiator and the gasoline, it boils at 145 degrees.
Depending on the pressure.
I've done it.
Yeah, I was going to say because you can. So if you look at the thing that I just said his name earlier, race car guy, Smokey Unick. If you look at the stuff he did, he was actually running his fuel between 400 and 440. And the reason he was doing that, he was saying, so it's all about the hydrocarbon chain. How long is it? Right. So if you got diesel and kerosene, and that's what I was going to talk about earlier. So I'm going to borrow this just for a second. Okay. This column, I mean, if that's a 200-foot column in an oil refinery plant, You got different takeoffs along that column. Yeah, and as the temperature goes up the column, you're pulling off the different fuels. It's all the same stuff, but it's the hydrocarbon chain. So what are we doing with it by heating it up? We're reproducing that factory again, and we're saying, no, we want the hydrocarbon chain to be this. We want them all this size because we're rolling them through this temperature. So if I have differences in fuel, I've got to vary that temperature to result back to the same chain length, because those chain lengths are different based on the fuel. So if it's diesel, it's one thing, jet fuel, kerosene, get up to gasolines, white gas, like a Coleman lantern, that kind of thing, you know, I'm going to drop the temperature way down because it's already refined to some point, right, way beyond what gasoline is. So, and that's the other cool thing, you know, you can mix your fuels and
I got my vaporizer and I run on my car in the city. I went from 23 to 25 to 30 to 38. And I ran Coleman camping fuel, rubbing alcohol, different fuels.
Right.
All the additives left over. That's not cracking it. But on
Right.
a small test, I actually cracked it on a hot plate. I ran the engine off a hot plate.
right. So when you say you ran the engine off the hot plate, you're sucking the fumes off of the hot plate.
Dripping in the hot plate and sucking fumes.
That's what that is. It's a fuel injector spraying directly onto a hot plate. The hot plate's got veins in it that lets the air pass through.
Right. And that's exhaust gases going through there?
Exhaust gases is warming that plate.
Oh, okay.
And I've got a K-type thermocouple to know what the temperature of the unit is. So over here on the intake side where I suck those exhaust fumes through that and back into the intake, I can vary
It's basically.
so I can maintain temperature